Good afternoon. Good afternoon, everyone. I welcome you all for the 45th episode of Creative. I am Supriya Nayaka hosting this program. Sunshine is delicious, rain is refreshing, wind brace up, snow is accelerating. There is really no such things as bad weather, only different kinds of good weather. So many questions in mind, like what is good weather, how clouds are forming, weather and climate are both are same or different term. So many questions. Rain, how rain is going to form, how clouds are forming, in which shape clouds are we are able to see. So many questions in mind. I hope today we get all the answers for the questions. And before start into the session, I like to introduce our Creactive. Creactive. Cre means creativity, active means activeness. Together, Creactive. Knowledge Square is our tagline. Sharing of knowledge increases our knowledge or doubles our knowledge is our concept. And every Saturday, we are organizing online talks in between 3 to 4 on Zoom platform. And we are live streaming our program on our YouTube channel. We are inviting resource persons who are masters in their field, and we creating a platform to present their research thoughts and views, reviews, and observations to share with us. I thank all the resource persons for sharing their knowledge, and I welcome our today's resource person, Dr. G. Raju sir. Today's topic is challenges in understanding weather and weather forecasting. I like to invite Vijay Shri Madam to introduce today's speaker. Over to you, ma'am.
Thank you, Supriya. Thank you so much. And then good evening to sir. Sir, hope you recognize me.
Nice to see you. It's a surprise, really a good surprise, pleasant surprise. Well, thank you. Yes, thank you.
So, thanks, Supriya, for giving me this opportunity to introduce our own Garuda Raju sir, as we call him in office, G. Raju, very active person. And then I'll just start with his personal thing. He's called as Garudachar Raju. And then his last position in ISRO was Project Director, Megatropics Climate Satellite. ISRO Satellite Center, which is now called as URO Satellite Center. And then after that one, he was as a Dr. Brahma Prakash Professor at ISRO until 31st October 2012. He was there until the launch of our Megatropics mission in ISRO. Currently, he is visiting professor ECE, SET, and Aerospace at Jain University. He has completed his BE Electronics from Bangalore University, ME Electronics from BITS Pilani, then PhD in Electrical and Computer Engineering, University of Kansas, Lawrence, USA. Just brief about his highlights achievement. He has joined ISRO Ahmedabad, that is SAC Ahmedabad, as microwave engineer in 1972 and worked on microwave hardware and subsystems for spaceborne systems. He was a lead member in developing the first Indian remote sensing payload on Bhaskara 1 and 2 satellites. Antarctic Radar Project at the University of Kansas was his feather in the cap. Later, he was transferred to URSC Bangalore and he took a charge of project director of Megatropics Climate Satellite. This was a Indo-CNES, Indo-French collaboration satellite, which was launched on 12th October 2011. His honors and awards: he has got a J.D. Gupta Gold Medal in 1981 for the paper of meteorological and instrumentation, and then certificate for setting foot on the unmundane Scott South Pole, awarded by the US Antarctic Research Program in 1986. And he has many more laurels. His current activities since April 2013 till date, he is currently a professor in Electronics and Communications Engineering, School of Engineering and Technology and International Institute of Aerospace Engineering and Management, Jain University. He is responsible in getting 3 NAVIC IC receivers and 5 projects from ISRO to the university. He was felicitated award for the projects for MOES and ISRO to other universities. He was also associated with NASA ISRO SAR, that is proudly known as NISAR, at Jain and 2 other universities through mentoring of faculty in those universities. He has guided 8 PhD students in Jain University and has 3 on the subject. 3 have completed on the subjects, namely climate change, disaster monitoring, navigation systems and space weather, that is GNSS NAVIC, then spaceborne radar calibration under RESPOND program. Today, sir is here to deliver a seminar on challenges in understanding weather and weather forecast. And then where he is a expert in this field, we were associated with him in the office and now happy to listen to him after that too. Happy to see you, sir. And over to Supriya.
Thank you very much, ma'am. It's very, thank you. Sir, just unmute yourself, sir.
Thank you very much, Vijayshri, and for the nice words. And I'm very happy that 2 of my colleagues, that is Vijayshri and Srinath, with whom I was very closely associated for more than a decade in the project Mega Tropics. It gives me a lot of nostalgic memories, our arguments, discussions, etc. So I'm happy. So when Mr. Srinath asked me, I immediately agreed because the subject is very close to my heart. In fact, as Vijayshri also pointed out, the very first satellite project, Bhaskara 1, was for meteorology and climate. And the last project, Mega Tropics, was also for climate and ocean application. So I'll be happy to share with you, with the participants. I'm sure there are a lot of students, junior students, experts, knowledgeable people. But I would like to confess, though I have worked for 40 plus years in this field, I'm still learning. It's such a vast knowledge, so difficult, so complex. That's why I have given the title Challenges. Still a challenge to know what we understand by weather and climate, and also how to do the forecasting. It's still a daunting job. Whatever number of satellites you have launched, whatever be the algorithms you have developed, however, still there is something required. For example, I just want to quote 1 or 2 what I have read. There is a newspaper material when that is when Russia wanted to have a very big gathering of a G7 or G20 meetings in Strasbourg in Russia, around Russia. They were not sure whether the weather will cooperate or not. So what they did was a very interesting thing. They did a cloud seeding somewhere far away so that all the clouds should go there. So there should not be any clouds, rain-bearing clouds over the venue. Very interesting to note that. This is an old story. I hope whatever I heard is correct, but still possible because cloud seeding is the method of attracting clouds to another region and creating rainfall through airborne methods. So without taking much of your time, I've been given about 45 minutes to present. Let me start the very first slide. I will ask Supriya Madam to continue the slide sharing. Second slide, weather and climate. we will just look at what is weather, what is climate. All of us know, as Supriya also said, we always said bad. Certainly, there is no bad weather. We call it bad, but unfortunately, our habit is to call bad weather, foul weather, inclement weather. What is inclement? Harsh weather. Because we want to go to some particular our own program, and the rainfall is obstructing us. So we should not probably look at in that direction. Whereas the farmer is waiting. Crores of farmers are waiting for the rainfall, but we are not really welcoming the rainfall. So it's unfortunate, but this is true in almost all countries. However, let us worship, let us pray that we will have the good benefits of rainfall. And so we should have a normal weather. Normally, with the meteorological departments will tell you normal weather. Monsoon is normal this season. So they will have a normal value for several parameters. Which are the parameters? What are all the, so let us, before that, let us understand what is the difference between weather and climate. Weather is conditions of atmosphere at a specific time or time duration, or a day, or a few minutes, or an hour, or sometimes even days. We talk about weather in those scales of time. Mostly these are all short term, maybe a monthly, whatever. However, climate is a long term average of daily weather. It could be it is mostly we express in the form of a pattern of weather. Pattern of weather is nothing but climate. So when I say pattern, it could be over years, decades, or more. Whenever you see in the newspaper temperature, tomorrow's temperature also here, they will tell today, approximately, because this is the number averaged over 100 years. Over 100 years. Therefore, the weather is instantaneous or now, or today, or very close to the time in the time scale. Whereas climate is a long-term pattern of weather over a region, over a particular latitude. So this is the difference between weather and climate. Practically, weather, what are all the differences? There are practically no differences, only the time scale. Now, I would like to briefly outline what I'm going to talk today. Please go to the next slide, Supriya Madam. I just want to give a gist of my presentation. I would like to take maximum of 40-45 minutes. I think somebody, Supriya Madam, will warn me about the last, when I should stop. Otherwise, I'll keep talking.
Okay, sir.
Okay, so there is my habit to not to stop. Anyway, that's the gist of some 8 topics I'm talking. I made the general introductory remarks of our daily habits of calling bad weather, foul weather, etc. Let us not do that. Let us all welcome whatever be the weather, and that weather we have spoiled because of our habits. Let us understand the weather, if at all there is a change, climate change, that is all because of we have abused the resources. I'm talking globally. And that's why people are rushing how to control the sources or the causes of weather, such as environment, pollution, deforestation, etc., etc. There is a rush. Recently, you might have read in the newspapers that the IPCC, that is the Committee on Climate, International Committee on Climate, was thinking that 2100 there will be a big rise in the sea level. So I thought probably it will be my lifetime or our lifetime will be very close to that, or mine will be much earlier. However, they recently announced 2030. Please note, the climate change or the disaster is coming very soon. We are all responsible for that. We must try to understand, cooperate with the policymakers. For example, all the roads I saw on my own roads, nearly 3,000 trees were cut. That is the cause of, that kind of things is a cause of climate change or the disasters. Now, I will try to continue talking about What are all the parameters that we are looking when I talk weather or when I talk about climate? That is my second topic. The first topic, definitions, I have just completed. The third one is some important commonly used terms I will present. Then the general types of weather, like a typhoon, or it can be a cyclone or a tsunami. These are all the extreme weathers. We'll discuss a few things on that. And then we'll come to an important topic on what are clouds, what is water cycle. So there are a lot of importance given to this kind of topics today. For example, there is a mission called Aqua. Aqua means water, like we call Landsat or OceanSat. There is an Aqua satellite for water related research. Then we'll talk about a few examples of the space missions. And since I am close to the climate mission, mega tropics, I will highlight a few results so people can understand what the satellite can do in this particular requirement of weather forecasting. Then I will also touch upon a few other things like sea level rise. They're all important topics which we are observing. It only goes a few millimeters per year, but the way it is happening, the sea level may rise to about 60 meters. Please imagine 60 meters rise in sea level means Bombay will be closed, totally submerged. Many coastal region, zones will be lost. This is the kind of disaster we are expecting due to this climate change. And I will also explain when we say temperature and humidity, how do we measure these things? What instruments? Why are they required? So this is the way I will cover the entire topic. Let me start from the next, that is physical parameters of weather and climate. Please, general definitions of that. Okay, parameters of weather. Obviously, whenever you look at today's weather, they will tell you temperature. Temperature maximum and minimum, average, all those things are very important from the weather point of view. Then there will be humidity. Today, for example, humidity is 70+%. There is a prediction. If you are curious, you can look into the website. There it might rain at about 4 o'clock or 5 o'clock when the humidity percentage goes up to 80+%. This is out of curiosity. I think all of you would be looking at it. Then cloudiness. Cloudiness is important. Okay, today there is a cloud cover. It will rain. It may not rain, but it's cloudy. It will make you very uncomfortable, or it may make you, may not make you comfortable. So this is another way of expression of what percentage of cloudiness. For example, aircraft will tell you visibility. How far I can see an object for landing before I land. That's where the pilot will be interested in knowing the visibility in maybe 100 meters or more, whether it is safe to land. This is another way of looking at the climate or the weather, today's weather. Atmospheric pressure. Always you will look at the pressure, you may not directly understand, but you will read from the weather report, there is a depression. There is a depression in Bay of Bengal. Therefore, Bangalore will be affected. There will be a continuous rainfall, what we call it Jadi Male. It will continue to, like it happened a few days back, 24 hours or 48 hours, continuous. That is the change in pressure. With the change in pressure, water vapor air will go up and up at a lower pressure level. When it goes up, temperature comes down. So the water vapor condenses. That is how the rain starts. So I will talk to you about a few things about that. Then we all know about the storms, hurricanes, tornadoes. Many of them are not really seen here. Okay, they are not really, I should say, they are not really seen in India. But however, they will be certainly seen in other parts of the country. They happen on the land. For example, cyclone is. I'm shifting to another room. Please hold on. I will continue talking. That's why you may see some disturbance in the background. Sorry for. So these are all the things I would be touching upon. What the real meaning of cyclone? What is a tornado? It may not happen over India. It happens in other parts of the country, of the world, and there will be typhoons. They're all in some form of cyclone only. And then tsunamis. I don't know how many of you have heard of the tsunamis that happened in the recent years, and there was a big devastation where thousands or tens of thousands of people died. So we'll discuss about a few of them. We don't have time to discuss everything. Please go to the next slide, madam. So parameters of climate are always there, but still there are some I would like to define. Whenever we talk about climate, they are all extended periods. I'm repeating whatever I had told. They'll be normally we'll cover the areas also, not only in respect to time, but with respect to latitudes. Tropical regions, we are all in tropical regions. So we'll talk about tropical climate. Tropical climate is very important because the activities that take place maximally with respect to water and heat exchange, that happens in the tropical belt. Okay, so that's, for example, India. That region is 20 degrees north to 23 degrees north to 23 degrees south. And temperate regions, most of they are all defined in terms of latitudes, higher latitudes. Of course, polar regions, North Pole region and South Pole region, they will be full of ice, and they are very dangerous in terms of, in case they are really going to melt. As I said, they're all freshwater zones, and if they all melt, if all the ice in the polar regions melt, the sea level may rise to 60 meters. Okay, that's what the work is going on, to see how much we can control, how much we can stop that kind of disaster. Then, of course, we have mountain meteorology, coastal and deserts, all very well known. Climates are all different types of based on the local geographical conditions. Next, please. Next slide. So what do you really see when you look at India IMD announcements? Announcement, what they will do is, normally they have a model. Here I am showing only one example where they will show the cloudy conditions as well as the wind speed and wind direction. There's nothing but a small line with 2 or 3 branches. If it is one branch, it is like 10 knots. That is, knots means, unfortunately, we are still going by the same terminology, but it's about 2.2 kilometers per second. Knots is a unit of velocity or speed, I should say speed, which is like 1.1 miles, which is equal to nearly 2 kilometers per second. This is the way you will see the distribution of wind field. When you go to the website of IMD regarding weather, they will give you all the, normally they give it for 5 days or more. That's called medium range weather forecast. Next, please. They will also give you advice. They will see, for example, recently there was a red alert, there was an orange alert. Orange alert means you should be careful. It may also come to a red, which means you have to be very, very careful. For example, green means no warning is required, you're comfortable. Yellow means watch for anything happening. Orange means be alert to vacate the place. For example, the fishermen or anybody living closer to the coastal regions. Red means you have to be totally inside. You should not venture outside. That's the kind of alerts that the IMD announcement for the weather warnings. Next, please. Temperate climates, I have already told you about this. Temperate climates, as I said, these are all based on the latitudes. And this is the latitude 40 degrees, 60 degree, north, south. That is the region where they call temperate climate. There are three basically: tropical, temperate, and polar. Polar regions always 67 degrees and above, and north as well as similar position in the south. This is just for a definition of what is meant by different types of region, different regions when you talk about the climate. Next one. Some common terms related to weather. Next one. See, I would like to bring out a few points, a few topics, or a few terms which are very important because of the time factor. I will address about 5 topics. I will talk briefly on those red ones. Let me list out. Climate change is a general term. What we always use. Global warming, because of our CFC and we are burning fossil fuel burning, temperature is increasing, or the heat is locked up within the temperature, within the atmosphere, within the closer to the earth. That is greenhouse effect. I'll give a little bit more on that. Ozone depletion, all of you know that because of the CFC, petroleum usage, the ozone layer is depleted. Therefore, what happens? The infrared, the UV rays, which are dangerous, they will come and affect the biological life on Earth. Then there is volcanic eruption is there. They are also part of the those which affect the climate. Then you have probably heard of El Nino and La Nina. They are all some very strange phenomena happening far away place, but still meteorologists have found a relationship with some changes and temperature in the oceans, in the Latin American regions happen. It may have some effect over India. Very strange, but it's true. They have correlated these things happening. That is El Nino and La Nina. It's nothing but the reversal of flow of winds from one zone, west to east and east to west. The temperature of the sea water changes. I'll explain a bit because it's not easy to explain without a picture. Then ocean circulation, that's another phenomena which will happen due to the wind conditions. Then one of the important topics I'm going to show in terms of results is global water and mass balance. That is, we still don't know on the large time scale whether ice or snowfall is increasing on the earth or decreasing. That is called snow, water, and mass balance. There is no balance or no balance, we don't know. There's a lot of work is going on, a lot of satellites are being launched. So everywhere there is a discussion on how to prevent depletion of ice or snow, not only from the mountainous regions, from the polar regions. Next one. So greenhouse gases, all of you know that I'll show in the form of a picture. The greenhouse gases are normally carbon dioxide, methane, and nitrous oxide. Next one. Please go to that. So this is how what is known as outgoing long wave radiation. That's a kind of belt as shown here. They are distributed. What is their role? We'll show in the next one. Next picture. So again, same. So this is, as I said, okay. The greenhouse effect is nothing but sun's radiation falling on the earth. They want to escape, but they don't escape because of the layer of the carbon dioxide. The atmosphere will stop the re-radiation backwards and they're trapped. That is how you all know why it is called in greenhouse in terms of using in the garden or in the field is to trap the sunlight or some advantages for the growth of the plant. That's why the term is used, but this is an important thing to know from the life on Earth, biological growth of the biological species. Okay, next, that is greenhouse effect. Next one. I told you about the El Nino. El Nino close to the coastal zone in Latin America, where they speak more of Spanish language. El Nino means small child. They have a convention that they have seen that convention. Why I say convention? Small child. Jesus Christ as a small child. That signifies the Christmas. So this happens. This is what happens is a warming of the ocean surface or above ocean surface or above, the average sea level changes. Therefore, there is a change in the, I'll show in the diagram that you know better. This happens around the change in the ocean temperature below the ocean surface. There's an inversion. That is not normal. That is abnormal. That is called El Nino. Why they call El Nino big? This happens during the Christmas. Christmas is recognized by the birth of Jesus Christ. Jesus Christ is considered a small boy. El Nino means small boy in their language, Spanish language. Let me come to the better. Yeah, this is the one where the water goes from west to east. This is El Nino year. Please look at the two pictures. There is a warm water going from below the sea surface from west to east. The reverse is called La Nina. There is, I'm honest, I don't know why this should happen. And I don't know why the people they are talking about this. However, it's a fact that when this happens, there's a large change in the weather. As I said, what happens in Latin America, almost 10,000 kilometers away, something happens in the ocean surface. There is a reaction in the Indian subcontinent. That is seen, that is observed. We don't know really. I'm not very much convinced personally, but I have seen, I have to believe that this has happened. So these are all the two things which were not, many of them are still on research. They'll create a feeling that the temperature rise, a heavy rainfall at some place can be related to El Nino. This has been seen over years. And when it happens over the years, statistically, one has to accept those theories. Next one. So this is the normal circulation of wind with respect to ocean surface. You can see this is called Walker circulation. When there is a change, next slide, just a term to remember, nothing much. The reversal of Walker circulation is called El Nino. What is the El Nino? This is where this picture shows that there is a change in the direction. There is a particular change that is not normal as we have seen. So this picture will tell you about the way the El Nino, this is purely El Nino, not La Nina. In the other picture, I had shown El Nino as well as La Nina. Look at the way the winds flow and the water temperature is changing towards one particular direction. Next one. La Nina. So same thing I have explained here. The reverse way, the temperature is, see, look at the temperature change from right to left. This is below the sea surface. Again, there is no proper explanation. I am not 100% convinced about some of these theories, but they are all proven quite well. Next one. This is another sea surface. This is what in a different way presented in the form of temperature changes in the actually detected by some of the satellites. Tropics Poseidon is one satellite, and AVHRR is our own. We also have, ISRO has a AVHRR. This is from some other. We have found out the temperature changes very clearly indicating the El Nino effect. Next one. Sir, this is nothing but sea surface temperature anomaly. Normal temperature is not observed, somewhat unexpected pattern of temperature below the sea surface. Yet, I would like to bring out a few things. You may be, sometimes I get confused, cyclones, tsunamis, hurricanes. So I wanted to share with you some features which some of the questions you may be asking yourself. So I would like to explain a few of them, not all of them. There's nothing but general types of weather anomalies, weather changes that we see. Cyclones, all of you know that, okay? And tsunamis, not many have seen. We have already faced one tsunami in 2004, where there was from the eastern hemisphere, there's a big rush of water. It is like a big wall of water flowing towards the coastal regions of India. And we had tens of thousands dying during that time. This is not known yet why it happens, why it should happen. But what is connected is deep under the ocean surface, several kilometers below the surface, it's about 10 to 15 kilometers, there's a big explosion. There could be an earthquake that violently shakes the ocean surface ocean body, and the big mass of water longitudinally moves towards the coastal regions, creating deadly damages. That is tsunamis. Cyclone, all of you know that there's a whirlpool of water and also atmospheric wind going around in a particular fashion, and also the cyclone moves in a particular direction based on the wind. Okay, typhoons and hurricanes, normally they are different forms. Based on the latitude only, they define these things. We are not, in India, we are not really going through that. And also tornadoes, storms and tide surges are all common in the coastal regions. Next one. Typhoon, as I have told you, this is about again another form of cyclone. It is normally in the, thank you, Dr. Narendranath. Yeah, so this region is referred to as the Northern Pacific Basin and the most active tropical cyclone. It is another form of cyclone, okay? But it's a function of latitude and the region. Next one. Please proceed, next slide. Supreme, okay. This is how they have shown, like, it is, as I said, it looks more like a normal cyclone only. This is one example which it happened in the Pacific region. Name is called Goni. Normally, you may be wondering, the annual start of cyclone will normally name them. The people, meteorologists name, starting with A in an alphabetical order. If I apply the same thing here, it is the 7th cyclone in that region globally happening. That is a convention, nothing else. Okay, next please. Yeah, I have explained in a slightly better way in terms of latitude cover, what is hurricane, what is typhoon, what is cyclone. So this is a geographical representation of these features, these what you call climatic events happening. Next one. Tornado again. One picture I'll show you in the next picture. They are like, please let us go to the next picture. I'll explain through the picture. This is nothing but a tower of air circulating like a big pillar. It moves. It moves toward the land. There will be vast damages normally happening over the land and creating big damages, lifting. I once experienced, there are not many tornadoes happening in the country, in our country. I imagine almost 45 years ago, I saw a tornado hitting Delhi region where the vehicles were thrown up to the first floor or second floor. That is the kind of strength these tornadoes have shown. You might have seen a lot of videos. They do a lot of damages to the property, especially when they reach a populated zone. Okay, next one. This is tornado. The pillar. Water cycle. We all talk about water. What is water cycle? All of you know. We have studied in our high school. But still, let us recapitulate that. May please go to the next one. It has got a cycle. Four particular zones or four particular features I have mentioned. Evaporation. In our college, as high school, we said when the sea level, when sea becomes warm, there is an evaporation, then it will become droplets of vapor and forms the cloud. That is correct. But there is a cycle, there is a way, there is a process. That is what is important. We have to understand for formation of rainfall. Whenever in my early days, when we were talking about the sea surface temperature, we were told, and we had a very big group of meteorologists. Many of you would have heard of Professor Pisharati. Is considered to be a father of meteorology or even remote sensing. He used to explain to us, even if there is a 1 degree change or half a degree change, that is rise in temperature of the sea surface, there is going to be a big onset of monsoon. These are all some, I may be wrong if by some numbers, but these are all the indicators of rainfall occurring, weather changes in the weather. That is caused by the evaporation. Why? Of course, it's because of sunlight heating the ocean surface. This is 90% of this water vapor in the atmosphere is due to the evaporation of seawater, and 10% is by transpiration. What is transpiration? We have studied in our high school. That is nothing but the breathing of the vapor by the plants, breathing of the vapor, water vapor content into the atmosphere. That's why we should be very careful about the contribution by the trees. Trees are the source of water. They also will reflect the heat, but mainly the trees are a source of rainfall. So all of us are advised, many times the people talk about planting more and more trees, afforestation, deforestation. A lot of trees are cut due to development. We have a lot of things and in the name of development. Forests are burned, forests are cut. But that's to be stopped. That's why the rainfall is erratic. Okay. Once these vapors are formed either by transpiration or evaporation, they go higher and higher. They go up and up into the atmosphere. They condense. They condense into droplet. So they become small drops of water. If it's heavy enough, it will become a raindrop. And
Madam Supriya, is it all right? Something wrong?
Okay, sir.
Okay.
an interruption. As I
Yeah.
said, there was some call for some visitors here. Anyway, I'm almost. If there, madam, I would like to stop for a few minutes. There is interruption, and I'll come back just next room. If you don't mind,
Okay, sir.
this is just. I will continue. Okay. So therefore, I would like to come to the last. I saw a question. I'll come back to the question, Narendranath, Dr. Narendranath. Yes. So then the precipitation occurs when the drops become heavier, and the drops will fall onto the earth. And depending upon the condition, there will be precipitation over a particular region. So this is the cycle: evaporation, transpiration, condensation, and precipitation. The total story about the rainfall. Next one, please. Cloud types. I'm in the last 2 or 3 topics. There are many different types of clouds, 10 main cloud types and subtypes. We will not go into the details of that now. However, let me come to the main ones only. Next one, please. There are three, basically cirrus, stratus, and cumulus. Cirrus means some kind of circulating cloud. As the word curl, it means, in Latin, it means curl, rotating. Often look like some tails of the heart, they are all rotating. If you can look at it, maybe if you can see some of the things in your actual real life, you can understand what are these. Stratus, they are all layered. Stratum, strata, that means they are all layered. Cumulus, they are all in hue, cumulative. So that's the way you have to remember the three types of clouds. Next one. Clouds are categorized based on there are different types. Low clouds, 2.5 kilometers. Medium, middle level it's just a question of convention. They are given based on these heights, all these three names, whatever I said. And there is one important thing called, please go continue. Next one. Cumulonimbus. Okay, formation of clouds. Clouds form when water vapor primarily, I have already explained, from the oceans, they raise into the atmosphere. When it cools and condenses, cloud is formed. The condensed droplets, they fall as precipitation. Rain clouds are nimbus. This is the kind of name again from the Latin language. They make also the kind of rainfall of it. I'm only telling the simple things what we know in normal terminology. It may be drizzle or it may go up to thunderstorms. Okay, these are all some of the cloud types. But what is important for you to remember or to understand is how the cloud is formed. Not all of them are rain bearing. Don't expect that every cloud will give you rainfall. No, wherever there is a droplet, based on the color, mostly they are all dark clouds. You normally see some cotton, a light white colored cloud. They won't give any rainfall. It should be heavy, dark, or gray colored. You can see today, sometime when you are traveling around, you can see those are the ones which give the rain. They are called rain-bearing clouds. Not all of them will be, not other types of clouds. Every day we see clouds in the space, but they are not rain-bearing clouds. Only those dark, heavily colored or heavily formed ones are giving you the rainfall. Next one, please. Nimbus clouds, that's a dark gray. This is the same thing I have told. Nimbus means rainstorm. So rains or nimbus clouds normally appear as dark gray. Okay, that's how you have to look for rainfall at that time. Now, whenever the cloud temperature goes very, very low in the higher level, they fall as small droplets of ice, hailstorms. So you have got not only drops, but there are hailstones. They are nothing but ice particles. Where water becomes ice at those higher altitudes. Next one, please. I want to give some examples of our own missions, OceanSat, megatropics, and scatterometer data, just to give you a taste of how the satellite takes pictures, how the satellite is able to help us in weather forecasting. Next one. OceanSat 1, please go ahead. OceanSat 1 was able to measure water vapor. This green belt is nothing but water vapor distribution over the entire globe. Okay, that's one example. Next one.
Sir, it looks like it is a Madras data, previous one.
Yeah, no, this Madras, this is similar to Madras, but OceanSat 2, OceanSat 1 had MSMR. It is exactly same frequencies as
Next slide is that.
Frequency.
Next slide
Yeah,
is that.
it's similar. It's similar to that. Yeah. So we had water vapor radiometer. It gave you water vapor distribution. We had sea surface temperature. Some of them are shown here. You can see here, Srinath, IRS P4, MSMR sea surface temperature.
Yes, sir.
If you what I'm showing off, sea surface temperature, water vapor. Thank you. Next one. Next one, please. It's about 20 years back, 1999. Same way, sea surface wind speed. They were able to find out the wind speed also. That's also one of the important. We tried our best to get maximum out of that, but wind speed is mostly it is to be done using scatterometer radars. But still, we overused or tried to make the best use of the MSMR radiometers, and this is the plot of all the such three parameters: wind speed, sea surface temperature, and humidity, water vapor. Thank you. Next one. Next one, please. Same thing. This is another way of water vapor. We'll come to megatropics. I think both Vijay Shri and Srinath are very familiar with this project. They did wonderful work during the project. I'm thankful for their very interesting. One of them, Vijay Shri, was the one who was trying to, her team was trying to give the data products and spacecraft control also. The mission group of Vijay Shri. And Srinath was the main person who was giving the prasadam. He was giving the data from his track. He was the one responsible for coordinating among other of his team members to give the data. So I feel nostalgic about this particular mission where both Vijay Shri and Srinath were part of this project. So why we have come, I will come to the more details of this thing. Tropical weather is very important because most of the water, ice, and most of the dynamic activities happens in the tropical regions. That's why we were very, very serious about Megha tropics. Come to that next one. Please come to the next slide. Megha tropics. Megha, all of you know, Megha is cloud. Is in the form in Sanskrit. Tropics, please see the change in the spelling. It was Indo-French collaboration. So we were covering the cloud properties. Cloud means water vapor, liquid water, rainfall, and cloud in the tropical regions of 23 degrees north to 23 degrees south. This is a very interesting, very successful mission. Please, let's go to the next one. This is the way it looks, megatropic satellite, just for general information. They're coming clockwise. Okay. So I'll come to the further things. Megatropics, what is megatropics? It is a climate satellite, and we had a very good set of results. Next one. It is a joint project where we were having the program to measure the dynamics of the tropical region with an inclined satellite, inclined at 20 degrees orbital inclination. When I say inclined, the orbital inclination. Next one. I'll show some results. These are all the frequencies which you had. Basically, it was meant for studying the cloud structure. That's called Madras. Saphir is for humidity. Scarab for radiation budget. And the fourth one is radio occultation sensor for the tropics ROSA. Next one, this is four payloads. This is general, what are all we have done. That's a very simple picture with including its track station. Okay. I'll join you in a few minutes. I'll please join in a few minutes.
Srinath sir, idr bagge neevu heli sir.
Or hele, meanwhile, for the audience, I'll just show the important what is available for the public domain. Can I share it?
Yes, sir. Just I'll show. Okay. You can share it.
Till he comes back. See, whenever we see the cloud coverages, how to understand the cloud coverage over India. This is the insert images which are launched by ISRO at 36,000 kilometers. It is there. This is half an hour back image. You can just check it.
Just mention that website address.
Website is rapidimd.gov.in. It is a joint collaboration of IMD and ISRO. You can see it's an insert 3D picture where you can try to understand over India. See what is the coverage of this particular satellite. If I zoom out, hope it is visible.
Yes, sir. Yes, sir.
See, from North Pole, almost it covers. If you see south up to Australia, it covers. So below Australia. So we are only more interested in an ocean because India being a peninsular country where as an Indian Ocean, Arabian Sea and Bay of Bengal is there. If you happen to see this one, you can change the vectors also here. You can put districts, all grid lines you can put. Thereby you can understand more clearly. See, the cloud coverage is indicated by white color, gray color, and the dark yellow, blue, and the dark orange colors will be indicated. For example, if you take now, see in the Western Ghats, it's there in the Arabian Sea. This is the cloud which is there in the Arabian Sea. It is right now, it is not affecting. Now, if you assume one grid now, from one grid to another grid moving, depending on the velocity, it will take around 1 hour or 2 hours, 3 hours. So if you are observing every 35 minutes, one image is available from the Indian satellite. So what you can see, the Karnataka place, if you see here, our place, wherever we are there, either Bangalore or Gauri Vidnur, mostly it is a gray clouds are there, which are not yielding, as Raju was mentioning. There are certain clouds which are they don't yield any rain, precipitations. So because of this reason only, yesterday and today, we don't have much rain, but it is still cloudy. Sometimes it will be sunny also. I just remove the grid so that we can see more clearly. This is how it, you can make animation in this one. You go to the options where you can make animations here. Animation is there. If I just say the number of frames, yes, come back. See now the cloud movement in morning to till now, like half an hour back. This is how the clouds are moving over the Indian subcontinent, especially South India. Many people may be wondering, and moreover, there is an alert given by the Met Department, like 27th of this month or June, the cyclone is going to come. This is the Indian thing. Similarly, you can have one more application to understand more, because it is not by one particular application you can understand the cloud or the weather. This is another important application called earth.nullschool.net, where they use global satellite data. This is one example I am showing here. See the globally how the wind, even if you see how outside in your house or in your place, wind or more cloud is moving from west towards the east. This is how it indicates. You just observe here the direction of the wind exactly at one location. And if you put point there, suppose if I put at Bangalore a little bit this side, I can know what is the wind speed. It is going around 26 km/h. This is even you can experience outside also. Globally, if wind speed is more on the either, say since monsoon, we are working on the monsoon now. I mean, we are approaching towards it. These are the monsoon winds. Slowly, it will bring. See, you look at below that how the wind direction is also changing. So here, one important element is sun is an what you called. He has lot of impact on the ocean. Here also you can change lot of. See, if you want to understand the what you call temperature. So I want to understand the global temperature. Just you look at here. This is how. See, North India is very hot now compared to the South India because of the cloud movement and other recent Assami and cyclone effects. Same way you can measure these things locally also you can measure. This is how it has both temperature as well as wind direction. Same way you can also understand the wind profiles, relative humidity. This is one such application where people can easily understand. Don't go by certain apps. These are the direct satellite data where being a, I mean, scientist, you yourself can do some kind of analysis. There are certain apps which will send you, Male barutte, it may rain, it may not rain, all those things. Similarly, there is one more application called as Windy. Many people may be familiar. There also you can understand a lot of things. I have installed an app. Windy app is a very genuine one. Or you can also use the web. This also shows similar to the. Saras, come back, madam. Please alert me.
Yeah, I'm there.
Yes, sir.
I'm there. I've just 3 minutes. There was a UGC visit.
No
so
problem,
I had
sir.
to show the Navic lab.
I have handed over to you because I didn't want to be idle
Thank
time.
you, sir.
Sir.
You have already taken care of many things. Can I start? Can I cut, Supriya madam?
Yes, sir. Yes, sir.
No
Yes, sir. Just
Yeah.
go ahead.
Yeah, no problem. No, we can relax. Now, Megha Tropics, as I have told you, I'll start again. Our very successful mission. I think Srinath might recently, he was telling me that there was a conclusion. It has worked for 10 years. Megha Tropics has worked for 10 years. Even now, it is quite active. Some parts of them, like stability, is gone bad, but it is a great satisfaction that it has done the required parameter measurements for climate, what we are talking today just now. Let us go to the next one, please. Okay, now, as just some time back, Mr. Srinath told, humidity. Humidity is one of the very important things that we had to measure. Have we missed some slides? Are we in the right sequence, madam? Go back. Okay, no, that's fine. That's fine. All right. Yeah, here I will, please go back that. Just I want to explain one slide before. Yeah, here I rushed. I want to explain what parameters we are measuring in this Megatropics mission. There is one satellite, one payload called Madras, Microwave Analysis and Detection of Rain and Atmospheric Structures. The very, it worked quite for 2 years, but afterward we had some problem. But it gave very good results, which I will show you in a few minutes. And I think I will not take more than 10 minutes hereafter. I think I have got enough time, if you allow me. Supriya, madam?
Yes, sir. Yes, sir. Go ahead.
I will continue. I will continue with my presentation from hereafter, because these are all our results, Indian results, and those have been very satisfactory for from the weather point of view. Now, there are 4 payloads. One is called Microwave Analysis and Detection of Rain and Atmospheric Structures, straight away related to the rain properties. The other one is humidity. Saphir is a humidity profiler. As I said in the very early slides, what is weather? Weather is made up of 3 or 4 important parameters: humidity, temperature, water vapor, and pressure. Please remember these 3-4 things: temperature, humidity, partly connected to the raindrop and all that. That's a condensed water. Then we have the pressure and the wind, of course. These are the main actors of a climate, main actors. So we have all the components of this, all the components, including the heat radiation measurement, the scanner for radiation budget. That means it will tell you what is the kind of temperature in the tropical regions in the atmosphere. I'm not talking about on the
Sir, your voice is not clear,
ground.
sir.
On the ground, we have many temperatures, face temperature, they measure the land temperature, the temperature in the air, or a radar. It's a passive radar.
I think he got disconnected. Something is there, madam.
Some network issue, sir.
No, I am back. Can you hear me now?
Yes, sir. Yes, sir. It's good.
I will cancel my video because the bandwidth issue may be there. That's why I'm telling you. Okay. As long as please let me know whether audible. Please let me know. Am I audible?
Yes, sir. 5 minutes more, sir.
Okay.
We take questions.
That is enough for me. I will not go more than that. Please go to the next slide. I will show some images how it looks like. Please go to the next slide. Next slide, madam. Can you? Next, keep going. Let me go to the results. Okay. A few pictures showing how the cyclone was caught, how cyclone movements were done. Those are the highlights of the next few pictures. This picture shows the concentration of cyclonic effects on the sea surface. This shows the movement of the cyclone in the ocean data. Next one. Let us keep going. Please go to the next one. Better ones are there. Because we don't have time. I don't want to explain too many. I don't want to consider too many. Please go to the next one. Are you able to hear me?
Yes, sir. Yes, sir.
Can you hear me? Hello?
Yes, sir.
The slide is not moving. Okay. This is the one. I would like you to understand that you see the right side, six rectangles are there. These are all the rectangles showing the humidity at different heights. The concentration of water vapor at different heights, not possible by normal sensors. Okay, this is one which shows. Please look at the left side. There is a starting to form a cyclone, as I show in the red arrow, which has grown into a full-fledged cyclone on the next 3 days, 27th December 2011, and 30th, it has grown into a full-fledged cyclone, which matches with the Kalpana satellite, which is another different wavelength satellite, that is for the geosynchronous satellite orbit. But you can see very clearly from microwave that the cyclone has formed. Next one, please. Can you hear me?
Yes, sir.
Yeah, please go to the next slide. I'm not seeing the indication moving in my speaker icon. Please go ahead.
Sir, it moving, sir. I'm changing this slide.
Yeah. Okay. Just to show you, I think you can share the PPT with those who are interested, and then they can study better and come back anytime. Okay. Radar scatterometer. Now I have talked so much about passive sensor. Passive in the sense it's only a receiver. Here I have a radar which can find out wind speed and wind direction from a scatterometer. Next one, these red lines are all small areas. Okay, this is showing the wind speed and wind direction from the scatterometer. Okay, please proceed. Next one. Now I will cover quickly 3 aspects. Sea level rise. Okay, this is can you make it, this is the way a weather radar works. You can see the swirling, rotating cyclonic storm. Next one. Are you seeing the changing features? This is way the radar works. Okay, sea level rise is a very serious problem for all of us. An altimeter can measure the sea level over a period of time. It measures what is an altimeter. It finds out the distance from the satellite to the ground. So this is the principle I have shown here. It measures the height, and the change in height will tell you the change caused by the sea surface level rise. Next one. Why are we worried about it? Next one. You are okay. That's right. Go to that important slide. No, before that. That graph, a plot I shown you. No, before that, please go back. This one, please, all of you look at it. This shows the rise in sea surface height. No, the next one. The results obtained by several spaceborne measurements, number of measurements, they show a trend of increasing sea level. As I said, we may not today worry about it, but if you look at the next few decades, certainly we are in a danger. Sea level is changing by a few millimeters, 3 to 4 millimeters every year. That is a serious cause to worry in climate change. Next one, temperature and humidity, as I already talked partly. There are some special frequencies in microwaves which will tell you about the frequency, the humidity at different altitude. This property is not available from any other sensor, but only microwaves can sense the atmospheric layers. This is a little bit more complex to explain. However, please understand that you have different type of lenses in your spectacles. Like you know that you are short sight, long sight, or what, nothing but I can see some distance which is far or some distance which is very near. But suppose there are in between lenses, I can see in between atmosphere which is equal to measuring the temperature or humidity at 2 kilometers, 10 kilometers, 5 kilometers, like that. This is the property of a sensor which we had on megatropics. That is called Saphir. Okay, please let us go. Little less time. This shows all the 3 channels, all the 6 channels of this particular sensor has been able to show the feature change, different features at different heights. Please look at the image. The image shows that at some altitudes, the features are different from the other altitudes. Sensor, this is the cyclone, which happened in June 2015, caught by the megatropics Saphir payload. Is the humidity sounder. It has detected the humidity at different altitudes. Why do we need humidity? Humidity for, and it is moving because of the winds, and that is what being caught by altitude. Next one, a few more slides. That's all. Yeah, this you already talked about. Next, you have gone backwards. Okay, repeated slide. Nothing but the picture shows the same. Okay, radio occultation. Last 2 more parameter, 2 more concept. Whenever you see, there's a very important topic called radio occultation.
One minute, sir.
Can you hear me?
Yes, sir. Yes, sir.
Yeah, I think there is for some time there is a problem. Okay.
1 minute, sir.
This is nothing but refraction. Yeah. Suppose you have the sun is passing through the atmosphere and refracted, and so the sun's rays are bending. By knowing the bending angle, people have found out the humidity. We don't need a very complex transmitter of opportunity, and so you have gone to the next. Madam, go to the last other one. You've gone too far. Next one, please. I think you wait for some time, otherwise you will be jumping. Please go to the next one. This is nothing but rays bending. So this shows, it's not very clear, but it shows the distribution of measurement locations globally by using this technique and GPS. GPS, global positioning systems, are able to give you this opportunity to measure the atmospheric temperature as shown in this curve. And we have this picture, this sensor on the megatropics. Next one. Next, I think few only. Very interesting topic I'm covering. I'm concluding with an interesting topic of cryosphere. Cryosphere means sea and ice studies. There was a story on this. Please hold on here. One aircraft was going in 1969 during the post-World War or even around that time, where an aircraft crashed. This was in Greenland. An aircraft crashed because there was a wrong information by the altimeter. What is the wrong information? There was a strong signal coming from the bottom of the ice thickness. This is you can see the layer, the 2 layers. You see the red one is the bottom layer, top one blue is the ice layer. That means there is a thick ice on the Greenland. The strong signal, what you see in the right, strong return signal from the radar, the pilot recognized that is the height, but that is not. A small signal has come from the top surface, you can see in the left, blue one. So he thought the strong signal is the surface where he can land, but he landed and crashed on the ice. Of course, there was no problem, no loss of life, because ice is a soft material on which this air crashed. But this found a beautiful theory. This found a beautiful application of a radar. Radar can penetrate through ice. Kilometer thickness of ice we can find out using a radar, which will go through the electromagnetic waves, can penetrate through the ice. Next one, last few of them. Please show next one. So I had an opportunity to do this in the Antarctic region. Please go to the next slide. Yeah, next one. That's I already told about that. This is explained here. We found an application for measuring the ice thickness. So some experiments were conducted by ground-based equipment like this crude system here, dragged on the ice surface in the Antarctic. Next one, the last picture. Next one. I jumped one, I think. Yeah, this is the last. Okay, that's the one, madam.
ಅಷ್ಟೇ ಸರ್.
ಇದೊಂದಿದೆ ತೋರಿಸ್ತಾರೆ ಅದಕ್ಕೆ ಮುಂಚೆ ಒಂದು ಕರ್ವ್ ಒಂದು ಕರ್ವ್ ತೋರಿಸ್ತಾರೆ. ಅದು ಇಂಪಾರ್ಟೆಂಟ್, ಅದೇ ಇಂಪಾರ್ಟೆಂಟ್. ಅಲ್ಲಿಗೆ ನಿಂತೋಗತ್ತಂದು. ಇನ್ನು ಮುಂದೆ ನೆಕ್ಸ್ಟ್ ಒನ್ ಬೈ ಒನ್ ಹೋಗಿ ಸ್ಲೋ ಹೋಗಿ ಯು ವಿಲ್ ಸಿ ದ ಲಾಸ್ಟ್ ಒನ್. ನೆಕ್ಸ್ಟ್ ಒನ್ ಹಿಂದಕ್ಕೆ ಹೋಗ್ತಾ ಇದ್ದೀರಾ? ಇದು ನೆಕ್ಸ್ಟ್ ಪ್ರೆಸ್ ಮಾಡಿ ಮೇಡಮ್. ಒಂದೇ ಒಂದು ಯು ವಿಲ್ ಸಿ ದ ನೆಕ್ಸ್ಟ್ ಒನ್. ನೆಕ್ಸ್ಟ್
ಇಲ್ಲ ಸರ್,
ಇತ್ತು ಮೇಡಮ್. ಅಲ್ಲೇ ಅದು ಮಿಸ್ ಆಯ್ತು, ಅಲ್ಲೆಲ್ಲ ಹೊಟ್ಟೋಯ್ತು. ಒಂದು ಗ್ರಾಫ್ ಅಲ್ಲ, ಮುಂದಕ್ಕೆ ಹೋಗ್ಬೇಕು.
ಗ್ರಾಫ್ ಸರ್,
ಅದೇ ಒಂದು ಕಲರ್
ಗ್ರಾಫ್.
ಗ್ರಾಫ್ ಇದೆಲ್ಲ ಇದಕ್ಕೆ ನೆಕ್ಸ್ಟ್ ಅದೇ ಲಾಸ್ಟ್ ಇದೆ. ಅದೇನೆ ಅದು ನೀವು ಬಂದು ಫ್ಲಾಶ್ ಆಗಿ ಹೊಟ್ಟೋಯ್ತದು. ನೀವು ಫಾಸ್ಟ್ ಆಗಿ ಮಾಡಿದಿರಾ? ಇದಕ್ಕಿಂತ ಮುಂಚೆ ಹೋಗಿ ಒಂದು ಎರಡು ಸ್ಲೋ ಹೋಗಿ.
ನೋ ಸರ್, ಅದೇ ಇರೋದು ಸರ್.
ಬಂತು ನೀವು ಒಂದು ಹಿಂದೆ ಹೋಗಿ ವೆಯ್ಟ್ ಮಾಡಿ. ಒಂದು ಹಿಂದೆ ಹೋಗ್ಬಿಟ್ಟು ವೆಯ್ಟ್ ಮಾಡಿ. ಇನ್ನು ಒಂದು ಹಿಂದೆ ಹೋಗಿ, ಇನ್ನು ಒಂದು ಹಿಂದೆ ಹೋಗಿ.
ಹಿಂದೆನಾ?
ಅಲ್ಲ, ಇಲ್ಲ ಮುಂದಕ್ಕೆ. ಅಯ್ಯೋ, ನೀವು ಹಿಂದೆಯಿಂದ ಈ ತರ, ಸಾರಿ, ಈ ಕಡೆಗೆ ನೀವು ಥ್ಯಾಂಕ್ ಯು ಬಂತಲ್ಲ, ಅದಕ್ಕಿಂತ 2 ಸ್ಲೈಡ್ ಮುಂಚೆ
ಸ್ಲೈಡ್ ನಂಬರ್ 82. ವೇಟೆಡ್ ಸ್ಲೈಡ್ ನಂಬರ್ 82.
ಓಕೆ,
ಇಲ್ಲ ಮುಂದಕ್ಕೆ ಹೋಗ್ಬೇಕು. ನಾ ಹೇಳ್ತೇನೆ, ಒಂದೇ ಸೆಕೆಂಡ್. ಇದೆ ಸಾಕು. ಇದು ಅಲ್ಲೇ ನಿಲ್ಸ್ಕೊಳ್ಳಿ ಮೇಡಮ್. Can you see this picture? This shows a very important result. That ice thickness measured is 1.2 kilometers. ಗೊತ್ತಾಯ್ತಾ? ಕಾಣುತ್ತಾ?
Yes sir.
Are you able to see in the left side, in the vertical scale, I have written 1.2 kilometers depth ice. The bottom layer is white layer idella. That is the one which is the rock. Above that is nothing but ice. So this is where Antarctic ice can be measured using a radar. This is one of the most important thing. And if we don't have a suitable space-borne radar, we can monitor whether the ice is forming or breaking and melting, and we'll avoid sea level rise. We have to monitor. This is the last one, madam. So you can close after this, because other two are already covered in a different way.
Okay.
This is the vertical profile. That is a cross section of ice. Green agirodella, except for the top layers and the bottom white layer, it's all ice. Aita?
Yes sir.
So thank you very much. We have covered most of it, and last few we had some issue, but I have completed that also. Thank you all. I hope something you could make out from my presentation. If there are any questions, I'll be ready to take. Thank you.
If any questions, you can ask. Only 2 we take. Any questions? You can unmute yourself and ask the questions.
Hello.
Ma'am, Vijayashri ma'am, you can ask.
Yeah.
I can ask, ma'am.
Yeah, you can.
Sir, why will acid rain occur, sir? And how will it occur, sir?
What on? Oxygen.
Acid rain.
How will acid rain occur, sir?
Acid rain is because of your industrial pollutants, no? Are you able to hear me?
Yes, sir.
Your microphone is unmuted. Okay, I can. Video is stopped. Okay. You are able to hear me, madam?
Yes, sir. Yes, sir.
Yeah. Acid rain is because of the chemical industries. No, they are not formed in the nature. They go in the form of, they are carried by the water vapor through evaporation. And also there are all these chimneys, chimneys from the industries. All these go high, they get transported to the upper surface of the clouds, the atmosphere. Therefore, they are the ones which cause this, as you can see those in the petroleum complex, that kind of areas, wherever you have more of chemical industries, okay?
Vijayashri ma'am.
Yes, ma'am.
Sir, good evening, sir. Actually, it was very informative, sir. All the time, sir. And then got to know many other things other than the megatropics. The last experiment about your Antarctic things, I think if you have any more details, maybe due to short of time, you are not able to explain how that particular experiment was conducted.
Yes.
So maybe we can take it as a question later. Or
yes.
I
Normally, it's a question.
Yes,
this is very, very close to my heart. I have been giving lectures to students, particularly to excite them about Antarctica and South Pole. Normally, I have about 100 slides exclusively for this topic. So if someone is interested, we can discuss more on that later, at a later time. Okay, Vijayashri?
Yes, sir. Yes, sir.
I gave a lecture in Isaac itself when I came first to Isaac. Anyway, that's a very old story, 15 years back.
Sir, okay, there is a questions in chat box. You can.
Okay. See, not able to see the.
What factor influence sometime late arrival and early arrival of Indian monsoon? What to do for sustainable development?
See, this is very difficult to answer. They will say it will come in. See, this time, you have heard that 3 days before it will arrive in Bombay. 3 days before, sorry, Cochin. Normally they have June 1st as the date of arrival of monsoon. And these are all based on simulation. Over years, there are a lot of algorithms written by various scientists, and the error is about 3 to 4 days. And that is continuing. We cannot predict all this because of the changing dynamic behavior of the wind conditions. Wind conditions are again due to the climate change. Climate change is a very big subject. Why somewhere, so as I said in one of the slides, when something happens in the almost 180 degrees out of location, that is Latin American coast, Brazil coast, we don't know yet. But yes, these are all statistically found out. They have models. One of the big good models, what we have heard is a 23 parameter model generated by, I don't know whether you remember the name of Professor Gavarikar. the Gavarikar model, the parameters need to be updated. Those parameters necessarily, then only you will get a good prediction. So, but yes, today we still have to live with this kind of errors. The errors are because of the different climatic conditions in the global scene, not in nearby scene. What happens somewhere else will have a teleconnection towards the monsoon of India. Today we have been told that monsoon will arrive 3 days in advance, 27th or 28th of May. Normally, the calendar is 1st of June. It will come towards the Kerala coast. 10th, it will come to Bombay. 20th or so, it will come to Gujarat. That is the timetable. But there are always errors because the dynamics is very fast. And we should have what is known as the mission like global. To solve that only, we have what is known as global precipitation mission. That is to find out the precipitation, onset of monsoon, etc. We have 8 satellites all around the globe looking for only one parameter, that is precipitation. So the question is very difficult to answer because why be delayed or why early, but this is a dynamic condition. If you really want to solve, we have to have more number of satellites which measure like the megatropics. Megatropics is giving you every 3 hours at some latitudes, every 3 to 4 hours. That is speciality of megatropics. Such measurements will give you a correct picture of the parameters measured. Those will be the inputs to your model, and your prediction will be much smoother. I'm sure you have understood the complexity, but this is still quite good nowadays. For example, today we have been told that 5-day advance, there will be continuously 5-day rainfall. This is quite good. They are stable over the land, but the dynamics of the oceans and all that we cannot predict. It is very difficult unless you make very good measurements. It is not possible to be more accurate than 3 to 4 days. Whenever they say so many days, 1st of June plus minus 3 days, now they are within the error bar. But that error should be reduced by better models. Thank you.
Okay.
Are you convinced
It's
about the
already
answer?
4:30. Sir,
Hello?
sir.
Whoever asked the question, I hope you are partly convinced about the answer. The difficult to answer, but this is the way, the reality is this. Okay, thank you.
Sir, one more question. Can you please difference between normal rainy cloud and those black clouds, sir?
Normal rainy clouds will have less condensed, you are whitish. They are more like whitish. They are called cirrus cloud. They are at high altitudes. They are like cotton structure. Whereas there are nimbus clouds. Nimbus means they are darker. They have more rain carrying clouds. Cirrus will not give any rainfall. Whereas nimbus and cumulonimbus, it also goes like a tower. That is very easily you can see in the open. You can try your this whatever I have said, cumulonimbus.
Sir? Sir, we are not able to hear you.
Like a light cotton. Okay, that's they don't give any rainfall. No.
Okay. Sir, it's already 4:30. We will end here.
Yeah.
Thank you, sir. Thank you very much for engaging us with your knowledge. It was very good, sir. It's a new topic for us regarding this. First time we are conducted this regarding this topic webinar. Thank you very much, sir.
You're welcome. It's my pleasure. I tried my best because the time was only, Srinath gave me only 1 day. You know, Srinath?
Yes, sir.
But still, I tried my best because from the day 1 to today, I'm studying only meteorology. Okay, thank you so much to all of you for
Yes.
being patient.
Okay. Thank you, sir. I'm ending here. Thank you very much.
Thank you so much.
Thank you.